Good evening. In this session, I am going to continue with the explanation of PYQs from Jeemain on the topic Newton's laws of motion and law of conservation of momentum. As I told you, this topic is very important. If you follow me carefully, it's 100% you are going to get one question for sure, 4 marks. Okay, so for one question you are going to get 4 marks. That's going to be given from this topic, laws of motion. See here, actually we have completed till I think in the last session we have completed up to 20 problems. See here, let us continue with this problem. Okay, a man of mass 50 kg and his son of mass 20 kg are standing on a frictionless surface facing each other. The man pushes his son so that he starts moving at a speed of 0.7 meters per second with respect to the man. Speed of the man with respect to the surface. Look here, the man, let this be the boy. The man pushes the boy with a velocity v1. As a result, the man moves back with a velocity v2 because initially both of them are rest on a frictionless surface. Initial momentum is 0. So, the total momentum after this is m1 v1 plus m2 v2 because there is no external force acting on the system. The man pushes his son in that direction. So, the man and son, they form a single system. Force exerted by the man on the son, it just becomes the internal force. As there is no external force acting on the system, the total momentum of after this is also 0. So, from this it is very clear, m1 v1 is equal to m2 v2. Here the interesting thing is, look here, man of mass m1, so 50, v1, you are supposed to find the speed of the man with respect to the surface, and m2 is given as 20. This is the most important thing. The man pushes the son so that he starts moving at 0.7 with respect to the man. As they are moving in opposite direction, velocity of the boy with respect to the man, v2 minus of minus v1, because they are moving in opposite direction, that is given as 0.7 meter per second, right? So, from this equation you can just find out. So, here m1 v1 is equal to minus of m2 v2 from that expression. So, here let us substitute the values. m1 is 50, you need to find out v1. Minus sign we are ignoring because you are supposed to find just the magnitude looking at the options. So, m2 is mass of the boy. From this v2 is equal to 0.7 minus v1. So, 0.7 minus v1. So, it is 50 v1 is equal to 20 into 0.7 minus 20 v1. Bringing this to this side, 70 v1 is equal to 14, or v1 is equal to 14 by 70, it is 2 by 10, or it is 0.2 meter per second. So, velocity of the man with respect to the ground is 0.2 meter per second. So, the beauty of the problem is you have to carefully understand this. The speed of the boy with respect to the man is given, and that is the relative velocity of the boy with respect to man is given. But you are supposed to find the speed of the man with respect to the ground. you are supposed to find the absolute velocity of the man is asked in the problem. Okay, let's move on to the next problem. A bullet of mass 20 grams, mass is given as 20 grams, has an initial speed u is equal to 1 meter per second. Just before it starts penetrating a mud wall of thickness S is equal to 20 centimeters. If the wall offers a mean resistance F is equal to, as it is offering resistance, direction of force is opposite to the velocity of the bullet. So, minus 2.5 into 10 to the power of minus 2 Newton. You are supposed to find the speed of the bullet after emerging from the other side of the wall is close to. So, here look, this is the initial velocity of the bullet. This is S. You are asked to find the velocity with which the bullet is emerging out of that wall or whatever. Now, look here. From this, you convert that mass to kg, because this is given in CGS system. So, this has to be converted into meters, that is 0.2 meters, mass is 20 into 10 to the power of minus 3 kg. From this, acceleration is force by mass. Find out the acceleration, force by mass. It is minus 2.5 into 10 to the power of minus 2 divided by 20 into 10 to the power of minus 3. 10 power minus 2, this is minus 1.25 meter per second square. You are supposed to find the speed of the bullet after emerging. So, initial velocity of the bullet is 1 meter per second, S is 0.2 meters, wall thickness is 20 centimeters, when converted to meters, 0.2 meters, A is minus 1.25 meter per second square. It is just a simple problem based on equations of motion. Final velocity is how much? What equation? V square minus u square is 2as. So, v square minus u square is 1 is equal to 2 a 1.25 with a negative sign into s. S is 0.2. So, this is v square is equal to 1 minus 2.5 into 2, 0.5. So, v is equal, v square is 0.5, v is equal to square root of 0.5 is equal to 0.7, v is equal to nearly 0.7 meter per second, because 0.7 square is 0.49, which is nearly equal to 0.5. So, velocity with which it emerges out is 0.7 meter per second. In this way you can do that problem, or if you want to use work energy theorem, Fs, work done against the force of resistance, is equal to lost energy, lost kinetic energy, half m u square minus v square is the lost kinetic energy. So, Fs is equal to half m u square minus v square. From that also straight away on substitution you can find out v. Okay. So, actually this is the shortcut method. Now, move on to the next problem. A block of mass 1 kg. Mass of the block is given as 1 kg moving along x-axis with a speed v is equal to 10 I meter per second, enters a rough region ranging from x is equal to 0.1 meter to x is equal to 1.9 meters. The retarding force acting on it is minus k x Newton. K is given as 10 Newton per meter. Then the final speed of the block as it crosses the rough region. Just if you work done is the lost kinetic energy, that is, see here, half m, lost kinetic energy is V1 square minus half m into V1 square minus V2 square. Work done is integral f dx if f is a variable function of distance mode. Now look here from this. So half, I am substituting, half mass is given as 1, V1 is given as 10, so that is 100 V1 square minus V2 square is equal to integral, initial velocity is along x axis, force is also along x axis. So integral k x, k is given as 10x, because actually we are taking from work energy theorem, work done is equal to change in kinetic energy. So lost kinetic energy is minus integral f dx. So minus of minus, this becomes plus. So kx dx. So here this is half m v square 100 10 square minus v2 square is equal to x square by 2 is the integral. X square by 2, limits are from 0.1 to 1.9. So half 100 minus V2 square is equal to half 1.9 square minus 0.1 square. You need to do the calculation part. 100 minus V2 square is equal to a square minus b square. Just for simplicity, simple calculation, a plus b into a minus b. So this becomes 100 minus V2 square is 1.9 plus 1 is 2, 1.9 minus 1 is 1.8. Okay. So here k is 10 Newton. So I think here there is 10, k is 10, so 10 into 10. So this becomes, if you take this to the other side and that this side, V2 square is equal to 100 minus 36, that is equal to 64. V2 is equal to root 64. Root 64 is 8 meter per second. So here the main thing is lost kinetic energy is work done against the applied force. That's it. Okay. Now let us move on to the next problem. A body of mass 500 grams moves along x-axis such that its velocity varies with displacement as v is equal to 10 root x. Force acting on the body. See here, we have already done this problem in the previous session. See, v square, starting from rest, v square is equal to 2ax. V square minus u square is 2as. Here if you square this, v square is equal to 10x. So 2a is equal to 10, a is equal to 5 meter per second square. Mass is given as 500. So mass is given as, see this is 2, oh, there is a, look here. Look, if you square this, v square is equal to 10 square, 100x. V square is equal to 2as. If you compare, 2a is equal to 100, a is equal to 50 meter per second square. M is equal to 500 grams to be converted into kg. To convert gram to kg, you have to multiply that with 10 power minus 3. So, acceleration is given as 50 meter per second square. F is equal to ma, it is 500 10 power minus 3 into 50, 1, 2, 3 zeros get cancelled, it is 25 Newton. So, the answer is 25 Newton. Is it okay? Let us move on to the next problem. Okay. See, look here. At any instant, the velocity of a particle of mass 500 grams is given as 2t I bar plus 3t square j bar in meter per second. Force acting on a particle at t is equal to 1 second is F is equal to I plus xj. Then the value of x is, see here, at any instant velocity of a particle is given like this. So, at t is equal to 1 second, this is the force. So, first of all, force is equal to this much. So, what is the acceleration? First of all, from this velocity expression, let us try to find out the acceleration. We can find out the acceleration by differentiating velocity with respect to time. See here, differentiate this with respect to time. Derivative of t is 1, so 2i. Derivative of t square is 2t, so 2t j bar. So, acceleration is 2i plus 6t j bar, right. So, at t is equal to 1, acceleration is 2i plus 6j meter per second square. That is the acceleration at t is equal to 1. From this expression of force, mass is given as 500 grams, that is 0.5 kg. Look here, from this expression, acceleration is force by mass, that is 1 by 0.5 into I plus xj. 1 by 0.5 is 2. So, this is 2I plus 2xj is the acceleration at t is equal to 1 second from the force expression. From the velocity expression, this is acceleration. Comparing these two, you see here, comparing these two expressions, I coefficients are same, j coefficients must also be the same. So, 2x is equal to 6. So, x is equal to 6 by 2, that is 3. That is the answer. Okay, simple problem, but it's beautifully set problem. Now, look into the next problem. A ball of mass 200 grams rests on a vertical post of height 20 meters. This is a vertical post of height 20 meters. A ball is resting on that. It is hit in the horizontal direction. So, look, a bullet of mass hits this in the horizontal direction. After collision, both of them travel independently. Ball hits the ground at 30 meters. Ball hits the ground at 30 meters and the bullet hits the ground at 120 meters from the foot of the tower. This distance is 30 and this distance is 120. Value of initial velocity of the bullet. See, there is so much data given, but it is simple problem, just like a body projected horizontally from the top of the tower. If you look at the bullet alone, bullet is given an initial velocity u when it is at the ball is given an initial velocity u at when it is at the top of the tower. Okay, and bullet is also given with some other initial velocity different from this, and it strikes. What is asked? What is the initial velocity of the bullet? So you have to bother about the bullet alone. So we are nothing to do with the ball at all. We are bothered about the bullet alone. So as far as the bullet is concerned, let us consider, look here, the ball hits at 30, the bullet hits at 120. See, this is 120 meters. Height is given as 20. What is the velocity of the bullet? If you forget the rest of the problem, just a bullet is fired horizontally from the top of a tower of height 20 meters, and this is the horizontal distance at which it strikes. What is the relation? X is equal to u into t, that is square root of 2h by g, from which what will be the velocity? So x is given as 120, this is u, 2, h is given as 20, g is given as 10. So u is equal to 120 by square root of 4 is 2, it is just 60 meter per second. This is quite interesting. There is lot of data given, but most of it is redundant. We are interested only in the bullet. So bullet is fired with a velocity u from the top of the tower of height h. It strikes the ground at a distance x from the foot of the tower. What is the velocity? So the relation is x is ut, where t is square root of 2h by g, from which we could get the value of u. Okay. Now next problem, 27th. A force acts for 20 seconds on a body of mass 20 kg. I am just writing the data. Starting from rest, initial velocity is 0, after which the force ceases and then the body describes 50 meters in the next 10 seconds. So in the next 10 seconds, look here, starting from rest, after which the force ceases to act, it moves a distance of 50 meters. S is equal to 50 meters in time t is equal to 10 seconds. Force ceases to act implies acceleration is equal to 0. So what is the force? So here S is equal to, from this S is equal to ut plus half at square. So when force is stopped, S is equal to u into t, from which u is equal to 50 by 10, it is 5 meter per second. Follow this very carefully. Let A be the initial point where the velocity is 0. B be the point beyond which force is equal to 0. C is the point for which it has moved through a distance of 50 meters in 10 seconds. So if you consider the journey from A to B, initial velocity is 0. Its final velocity is velocity at the point B. velocity at the point B. If you consider the journey B to C, its velocity is uniform because force is 0, acceleration is 0. So, from B to C, its velocity is constant, that is 5. So, at B, its velocity is 5 meter per second, right? Then, what is the value of this force acts on the body for 20 seconds. So, what is acceleration? Because you are asked to find the force. To find the force, you need to find out acceleration. Acceleration is v minus u by t. It is 5 by 20. It is 5 by 20 acceleration. So, force is equal to m into a. Mass is given as 20. Acceleration is found to be 5 by 20. So, force is equal to 5 Newton, that is the answer. Okay. So, I am repeating that problem. Look here. Force acts for 20 seconds, that is from A to B, force acts. Initially, the body starts from rest. So, if you consider the journey from A to B, u is equal to 0. V we do not know, velocity at B is not given initially, time of action of force is 20. But you are supposed to find the force in those 20 seconds. So, if you find the acceleration from A to B, we can find out the force. So, to find the acceleration, the next data is given. When the force ceases acts, the body travels 50 meters in next 10 seconds. When the force is 0, then displacement is equal to velocity into time, or velocity is equal to displacement by time. It is 5 meter per second. So, that 5 meter per second is velocity at B. Substituting that in this expression, acceleration is found. So, force is F is equal to ma, right? Now, look into this problem. Velocity of a bullet becomes 1/3. So, if this is the initial velocity, it emerges out with 1/3 velocity after penetrating through a plank of 4 centimeters. Assuming that the bullet is facing a constant force during its motion in the block. Bullet stops completely, meaning here if this thickness is 4 plus x centimeters, bullet stops completely. Final velocity is 0. So, the value of x. See here from this equation, v square minus u square is equal to 2as. As resistance is offered, this becomes v square minus u square, or directly you can say u square minus v square is 2as. Same force of resistance is offered. As 2a is constant, s is proportional to u square minus v square. That is the concept we have to understand. See, in the second case, s is 4 plus x. In the first case, s is 4. As you are taking the ratio, this is in centimeter, this is in centimeter ratio. So, you need not convert that into meters. U square minus v square. In the second case, u square, final velocity is 0. In the first case, u square minus u by 3 whole square, that is u square by 9. Simplify this carefully, you have to find out x here. So, 4 plus x by 4 is equal to, you can take that u square as a common factor, 1 minus 1 by 9. This implies 4 plus x by 4 is 1 minus 1 by 9 is 8 by 9. So, it becomes, in the denominator it is 8 by 9, 9 goes up. So, this is 2. If you apply cross multiplication, 2 4s are 8. 8 plus 2x is equal to 9. 2x is equal to 9 minus 8, it is 1. X is equal to 1 by 2, that is 0.5. Because all the distances are given in centimeters, x is equal to 0.5 centimeters. This is the correct choice for that problem. Okay, so here as it is experiencing the same force of resistance when it is travelling in that slab, S is proportional to u square minus v square. From that we could solve that problem. Let us go to the next one. An object of mass 5 kg is thrown vertically up from the ground. Air resistance produces constant retarding force 10 Newton. This is the retarding force, meaning the direction of retarding force is opposite to the direction of motion of the body. Throughout the motion, ratio of time of ascent and time of descent. So, during its ascent, initial velocity, see maximum height is h. Okay. So, here what is its time of ascent is square root of 2h by, what is the formula? G is in this direction. As the body is moving in the upward direction, acceleration is also in the downward direction. That is retardation produced due to the air resistance is downwards. So, time of ascent is square root of 2h by g plus a. And similarly, if you consider the descent, so time of descent when it is moving down from the same height, it is square root of 2h by g. Look here very carefully. It is moving in the downward direction. G is in the downward direction, but its force of resistance is opposite to it. So, it becomes square root of 2h by g minus a. Okay. So, you are supposed to find the ratio of time of ascent and time of descent. So, from these two expressions, time of ascent by time of descent is equal to square root of g minus a by g plus a. If you find acceleration or retardation due to air resistance, problem is done. So, resistance force is constant, that is 10. So, it is 10 by force by mass, mass is 5. 10 by 5, it is 2. So, this is g minus a, g value is given as 10, a is 2, this is 10 plus 2. This is square root of 8 by 12. So, 4 gets cancelled 2 times, here 3 times. So, the answer is square root of 2 root 2 is to root 3 is the answer. Is it okay? So, if maximum height reached is h, time of ascent is square root of 2h by g in absence of air resistance. But when the body is moving up, g is downwards, a is downwards. So, when air resistance is considered, time of ascent is square root of 2h by g plus a. When it is falling down from the same height h, time of descent is square root of 2h by g in absence of air resistance. When air resistance is there, it is like this. So, it is square root of 2h by g minus a.